This is a production of Cornell University.
Oh, here we go. Good. This is what Brussels sprouts look like. Brussels sprouts were invented in Belgium, and the main capital of Belgium is called Brussels, and that's where they get their name. And it's good to remember that, because Belgium is in the northwestern portion of Europe, where a lot of fertile soil right on the seashore. It's a maritime climate that is characterized by long and relatively cool summers with frequent rain and a long, mild winter. Very long days in the summertime. It's quite a bit farther north than where we are right now. And to find similar kinds of conditions, relatively mild growing conditions in North America, you really have to go to coastal California, parts of Washington State, northern Washington State, coastal areas of Oregon, and also in the wintertime in Mexico, the Baja Peninsula, and some of the higher elevations in Mexico, central Mexico. When we're talking about climate on the East Coast, we're really talking about a continental climate. So our summers are short, but very intense. Things get warm very quick in the spring, as you know, and there's a quick period of a lot of heat and stress, either torrential rain or no rain at all. And then before you know it, it's wintertime again. If we take a look at the fertility requirements for Brussels sprouts, here you have an interesting slide, and we're going to spend a little bit of time on this slide. You can see the fertility recommendations there for phosphorus, for nitrogen, potash. Then we have sulfur. Brassica crops need quite a bit of sulfur, some magnesium, and some calcium. And these are listed here in kilograms per hectare, which is pretty much the same thing as pounds per acre. So you can pretty much translate that directly. And then what you see in, this is a slide from Northern Europe, and they can plant pretty early in April already. We may not be able to get on the ground yet in April. We may have to delay it a little bit, but for all practical purposes, you see the crop progression, and you can see the plant development from planting all the way until midsummer and then late summer as we go along here. You can see a crop progression like this. Plants reach the full height under ideal conditions by mid to late summer, and then the sprouts begin to develop, and you can see that the sprouts develop from the bottom on up, going up the stem as the season progresses, and you also see that the leaves begin to fall off. You can see that phosphorus is taken up in the early part of the season to form a strong root system, of course, but once the root system is established, not much more phosphorus is needed. Most of the potassium is taken up early in the season. That has to do with the development of the stalk and the development of the plant. So basically, a lot of the potash is used to develop the structure that is ultimately support the Brussels sprouts. And then nitrogen uptake is progressively increases, but then levels off and then trails off towards the end of the season. And I'm going to spend a little bit of time on this slide because it's important to understand why this is. You can see that nitrogen uptake is pretty strong while the plant is developing, but once the plant has developed its maximum height, it begins to reallocate its resources from leaf production to sprout production. And you can see that a lot of the nutrients that are used to produce the sprouts are basically nutrients that have been redistributed out of the leaves and into the developing sprouts. If there is enough nitrogen in the soil, you should be able to let this plant continue to develop, and it will develop just like this. If, however, for some reason, you have a wet summer like we had this last year, and you lose a lot of the nutrients, you may be short of nitrogen at that point. And what then is going to happen is the plant is going to cannibalize the lower sprouts, redistribute the nutrients out of the lower sprouts to feed the top sprouts. In another situation, for instance, if you have too much fertility is going to stimulate leaf growth, and it's going to prevent some of these lower leaves from starving, and it's going to keep those leaves green. So if you have too much fertility, you have a plant that has a lot of leaves on it, and they have to really dig around in there to find the sprouts. If you don't have enough fertility, then you're going to see that the lower sprouts are going to lose quality because they lose nutrients, the tissues become weak, and they become much more susceptible to invasion by pests and diseases. My computer is a little slow to respond, sorry. So we have this depiction of an ideal situation. You get rapid growth in the first half of the season. So you need to really fertilize the sprouts quite heavily in the first part of the season. So basically front load most of your fertilizer and then keep a little bit of nitrogen for side dressing later on in the season. The plants should reach their maximum height towards the second half of the season. The fertility should be mostly used up by the end of the season so that the nutrients that are in the leaves can be redistributed to form the sprouts. But then the leaves should die off and fall off so that you have these nice naked stems with nice green and not funky sprouts. And then we'll talk a little bit about topping of the plants towards the end of the presentation. This is the ideal situation, and you can see exactly what is happening, exactly what we showed in the slide that I showed you a little bit earlier. You can see nice straight stems, nice even distribution of sizing of sprouts all the way up and down the stem. The sprouts are nice and green. There's no yellow sprouts except for this one over here. They can begin to develop a little yellow wing. So, but you can also see that the leaves have basically been used up. The leaves have fallen down to the bottom of the ground. These sprouts have been topped. And so pretty much the top of the stem is gone. Most of the top leaves are gone. And you have nice development of the sprouts all the way to the top. This is an ideal situation. But we are not in Belgium, and our situation for growing Brussels sprouts is not ideal. The reality of the situation is that we have heat stress in midsummer, and when it's really hot, the Brussels sprouts don't like it. They don't grow anymore. They may not necessarily wilt, but they will not grow anymore either. That means that you get loss of production. The stems are going to be shorter. Water stress is going to lead to calcium deficiency, same as you see in blossom end rot in peppers and tomatoes, for instance. That will ultimately result in internal breakdown of tissues of the sprouts, internal tip burn, or sometimes some external tip burn, and the crop maturity could be delayed. When there is no growth, that means that the top bud is dormant and is no longer exerting apical dominance. And that means that if there is any kind of regrowth, so you get a little bit cooler weather or you get a bit of rain, that means that the bottom sprouts are basically have gained their independence at that point, and they begin to start sizing up, while the top sprouts haven't even started to developing yet. So you get uneven sizing. That means oversized sprouts at the bottom and undersized sprouts at the top. The oversized sprouts are over mature too quickly. They become weak, they begin to stretch, they become susceptible to invasion by diseases, etc. And then, of course, what we learned in 2021, when we had a wet summer, the loss of nutrients towards the end of the season results in a weakened crop that is also more susceptible to diseases. So what do you do to avoid some of these stresses? Well, irrigate in midsummer if you can. Sometimes you can avoid some of this stressful period by planting a little earlier and making sure you get lots of growth on the plant before stress comes in, usually in July. Use varieties that are relatively vigorous, so they can make that extra growth and can grow through some of the stress. But which variety is best for you depends a little bit on your particular situation, and you'll have to experiment with varieties a little bit to find out which variety has the right vigor for your ground and has the right maturity for your market. And how much fertilizer should you use? Well, the recommendations that I showed you earlier are really based on ideal situations in Belgium, and that means that the crop is never stressed and is always growing, so therefore is very productive, but then also takes up more nutrients. I think the numbers that I show here are a little reduction by about 30% or so of the top numbers that I gave you earlier. If you have good ground and you have good irrigation and you have a productive year, they're probably going to need more fertilizer. If it's a stressful year, they're probably not going to need as much. That makes sense, I think. Here's a little study that we did in our farm in Geneva, where we look at the effect of planting time. And we planted 3 different varieties, Divino, Marta, and Degen, from left to right, Divino, Marta, Degen, with a couple of guard rows of Franklin. You can see the pale green guard rows of Franklin on the outside. And we planted them in May, June, and July. And then we evaluated towards end of October, beginning November. And what do we see? At harvest time, we see in the May planting that we get good sprout development. The plants are beginning to look a little tired, as you would like to see in Brussels sprouts. Some of them are over mature, but we have good yield here. If you look at the planting that was made in June, the plants are healthier looking, a little bit more upright. The top sprouts are still a bit small in this planting, but the stalks have reached good length, so we're not altogether unhappy about this planting. And then you see what happened in July. These plants look perfectly happy, but there's no sprouts in them because they were planted right in the stressful period, and they stood around doing nothing for about 6 weeks before the weather got cooler and they started to grow. The sprouts are really nice and clean, but there's hardly any sprouts there. They're low yield. And here's a close-up. This is a variety that has medium vigor, I would say, decent to medium vigor. This is Degen, planted in May, June, and July. You can see the lower sprouts are developing very nicely. The lower leaves are beginning to fall off. The middle sprouts are beginning to develop. The top sprouts are still not quite there. But if you looked at the later planting, you see fewer sprouts at the top, decent sprout development at the bottom, decent quality, middle sprouts a little smaller, and in July, just a few sprouts at the bottom, nothing in the middle and nothing at the top. So from this picture, you would say May, June is probably a good time for planting Brussels sprouts in our area. This is Marte. This is a little bit stronger variety, a little bit more vigor, and also good field holding. You can see the same story here. Very good sprout development and beginning to fill nicely at the top already from a May planting, and the lower sprout quality is still acceptable. June, a little bit behind in development, but because of good vigor, it grew through the stress fairly well. And so the difference between a May and June planting is not that big, but definitely a July planting, not enough yield, not enough sprout fill at the top. Here's another variety. This is Divino, very popular in California, but it doesn't work for us very well because it's not very vigorous, and so it's very susceptible to stress. And you can see that a little bit here. It needs a lot of time to be able to do something through a stressful summer. May planting is good. The June planting, very small sprouts, just barely beginning to develop. And remember, we're in November now, so not much time to make sprouts anymore. And July, basically, hardly anything there. This is what you see in a wet summer. This is what we talked about before. You can see that the lower leaves have fallen off and they're laying on the ground here, and those nutrients have been redistributed to form these sprouts. But it was a wet summer, a lot of water, a lot of the nutrients have washed out. And while the top sprouts are beginning to fill, the nutrients that are needed to fill those top sprouts don't come from the ground anymore, but come from the lower sprouts. And that makes those lower sprouts much more susceptible to attack by fungi and in some cases bacteria. But Alternaria is quite often what you see in these lower sprouts. So you take this to a phytopathologist and they say, yeah, it's Alternaria. So we're always worried about spraying fungicides to keep these lower sprouts clean. But really what is happening here is that these sprouts have run out of fertility. And you know it yourself. If you have a crop that is hungry, it gets very susceptible to disease, and there's no amount of spraying to keep that crop going. It really needs to be fed. You can see in this same field that was managed a little bit differently. There was some early planting, there were some later plantings. You can see the same thing. This is an early planting of Degen, and you can see that the lower sprouts are beginning to get ugly. Whereas this is a later planting. So that basically means that even though some of the fertility washed out, a lot of the fertility that was taken up by these plants early on in the season was still available for these plants. So these plants basically had a little bit more feed, and therefore from a slightly later planting suffered less from nutrient loss and provided a better crop. This is a new variety of our Sylvia, similar kind of a story. An early planting, lower sprouts, decent, holding up fairly well on Sylvia, but still beginning to see a little bit of quality issues, whereas a later planting just was able to take advantage of whatever fertility was still left in that field. But this is basically a situation where the grower did not top dress, And you can see that the lack of fertility, especially in early plantings, leads to quality issues. Let's talk about some of these quality issues. Some of the quality issues that you see that we call it, the funkiness of the lower sprouts is a result of a physiological disorder, tip burn, calcium deficiency, also called summer frost sometimes, and is caused by environmental stress. So you have water transport to some of the leaves, but not to the young developing tissues, leading to calcium deficiency, and also things like uneven growth can make development of the sprouts as premature. As we talked about, the lower sprouts can become develop too quickly and become over mature. And then what you see then in these weak tissues, that Alternaria invades these tissues, but Alternaria is not the primary cause. It is environmental stress, it's fertility stress, it's uneven growth. So what to do about that is to make sure that you can even out the growth and alleviate some of that stress by either drainage, when the field is too wet, or irrigate when the field is too dry, and side dress some nitrogen when you see that the quality of the lower sprouts is beginning to decline. And you can see here exactly what I mean. This is the top sprouts of the plant. The top sprouts are where the plant invests most of its energy. This is the youth. This is the future. So we invest in the future, and these sprouts are actively growing and getting all the nutrients they need at the expense of other structures in the plant. And the other structures in the plant are often the lower sprouts. So I took some of the lower sprouts from that same plant. I tried to clean them up a little bit, but you can see that I had to do quite a bit of trimming to get the outer leaves that are dirty off of there. And even after some hard trimming, these sprouts are not nearly as good and as clean. You can also see they're beginning to open up a little bit, and that there's some problems associated with that as well. A close-up look of some funky sprouts at the bottom of the stem. I think most of you who have grown Brussels sprouts over the course of the past several years have seen some of these things and have wondered what to do about that. And you can see another close-up. Snails get in there sometimes, but you can also see yellowing of these tissues. That basically means they're nitrogen efficient. Nitrogen is being taken out of these sprouts to feed the upper sprouts, the young sprouts. And what you can see at these lower sprouts is that if you get uneven growth, that the sprouts begin to elongate. So apical dominance is lost. That means that the lower sprouts are going to make their own stems. And you can see that they're fully prepared to do that. And they're even fully prepared to make stems that have little sprouts on them. Because after all, that's what Brussels sprouts do, don't they? And then a close-up of that is you can see exactly what happens when these sprouts begin to elongate. They get loose. And you can also see that because these little wrapper leaves, these leaves that go over the top of the Brussels sprout, as this sprout begins to stretch, they get detached from the stem. That means that they die. And of course, dying tissues, again, become very susceptible to saprophytic fungi like Alternaria. And then you see this nice little aphid that's walking around over here. This aphid is on a little walk because he has a beautiful home in this Brussels sprout, nicely protected. And it's important to keep sprouts nice and tight and to not deny these aphids an opportunity to hide from enemies and from insecticides. This is an extreme case at the very bottom of this Brussels sprout plant, way over mature. These Brussels sprouts are beginning to bloom out and bud out. You see a close-up here of this Brussels sprout in my hand, and you can see that this is a nice little stem with a crown of little leaves and little mini sprouts on the side. If you can find somebody that gives you top dollar for mini sprouts, maybe this is a way to save your income, but I think we all realize that this is pretty much a lost cause. Then we can see what the effect is of summer frost. This internal calcium deficiency leads to internal tip burn. You see these kinds of things, and those of you who have grown cabbage do recognize this, that tip burn can be a real problem, especially during hot and dry summers. Not always necessarily obvious from the outside, but once you cut the cabbage open, or if you cut the sprouts open, you can see that quite easily. Similar to blossom end rot in tomatoes and peppers, and I'm sure most of you are familiar with that story. It's not calcium deficiency in the soil, it's just a lack of water to help distribute that calcium from the soil to the young developing tissues. And when those tissues become calcium deficient, of course, they're prone to collapse when there's a little bit of stress, and that's exactly what you see here. It can be internal, but it can also be external. And here's a nice example of what you call that summer frost. It almost looks like, you know, this tip burn on the outside, and you can see that Alternaria is already going to town on these tip burned leaves. This is the outside of the sprout. This is one layer in, still happening. This is 2 layers in. This is 3 layers in, and then you have to really get into the middle of the sprout before you get something clean. But again, this sprout is not marketable. What you then sometimes also see is that you get some of these tissues that are weakened, but can become susceptible, or bacteria can invade them. So now you get some of these tip burned or weakened tissues. Soft rot bacteria get in there, and then you have a real mess. This is not pretty when this happens. I hope it never happens to you, but if it does happen, at least you have some indication that the crop was maybe just a little bit too stressed during the most stressful part of the growing season. And that then leads to bacterial problems later on. We know that thrips can be an issue in Brussels sprouts as well. Here's some examples. Not really sure what I can recommend to prevent that from happening. Some varieties clearly are a little bit more susceptible than others. I don't see it too much, but if you do see it and you say, boy, this is really too bad, because the rest of the plant was developing quite nicely, and then we do still see some of these this puckering that is the result of thrips feeding. Now let's talk a little bit about topping. When to top? Don't top until you're basically you have a market for your Brussels sprouts, and you have a customer that's ready to take them. About 10 days before you're ready to ship the Brussels sprouts, you take the top out, and that allows the last few sprouts at the very tip of the plant to grow a little bit more, and that means you get a little bit of extra yield. But be careful that you don't top until you're ready to sell, because if you plan too far ahead, you get this kind of a system. This sprout that was topped at the right time. You can see the top sprouts are beginning to get some decent size, begin to catch up to the size of the sprouts that are down below here. But very quickly, they will overshoot the size and then blow out, become bloomy. Because see, there is no top bud anymore. So we have these 4 or 5 Brussels sprouts at the top that are all fighting for dominance, and they're going to try and make a stem as quickly as they can. And that means basically, even though you topped to get more size, you're going to lose these sprouts anyway, because now they are too big. Brussels sprouts are much more challenging to grow than kale. Let me leave you with this image. Imagine that you're driving around in a car and you lose the brakes on that car. You're not in a mood to walk home, so you're going to try and make it home in this car without brakes. What do? You give it just enough gas to keep up the speed, but you don't want to go so fast that you're going to get into a bad accident. You're going to slow down a little bit, and by the time the car begins to slow down, you give it a little bit more gas to try to keep a moderate speed. Now you come up to the driveway, and you can kind of take a look at the driveway as the fertility of your soil. If you have poor soil, you basically have a driveway that goes uphill. If you want to get the car in the garage, you're going to have to give it a little bit of gas, or in this case, the Brussels sprouts, you're going to have to give them a little more nitrogen to make sure they make it to the end. And then you give them just enough so that they finish up just fine without making too many leaves, but also without the sprouts turning yellow. In other words, you're trying to get the car in the garage with just enough gas to get there. If you have a level driveway, that means moderate fertility in your field. Very easy does it. You don't want to give them too much fertility because still you could overshoot. You can build up too much speed, or in this case with Brussels sprouts, you can make too many leaves. If you have a downhill driveway, that means that your ground is too fertile already. You're going to have to take out a few fence posts maybe on the way to the garage to try to slow down the car. But the likelihood is that you're going to go right to the back wall of the garage. I hope that image helps you a little bit to think about how to grow Brussels sprouts. Brussels sprouts, good fertility in the beginning. Try to avoid stressful conditions as much as you can. fertilize them a little bit. If it looks like the quality of the lower sprouts is going south on you, don't fertilize so much that the leaves don't shed. It's a real touchy equilibrium. If you have a year where you have a lot of water and a lot of nutrient washout, it probably means you have to side dress a little bit more aggressively. If you have a dry year where the plants are a little bit stressed and not growing so much, you probably didn't lose that much nutrients. So you want to be careful about not side dressing the plant, especially not during the time when it's stressful, because the plants aren't taking anything up anyway. And so there will be plenty of fertility left for these plants to finish off just fine at the end of the season. But everybody's ground is different, every season is different, and every variety behaves a little bit differently. Some varieties are early maturing, some varieties mature a little bit later, some varieties are more vigorous, some varieties have less vigor. So it takes several years to understand how a variety grows, and it takes several years to figure out how to fertilize that crop, just so that you end up with that perfect Brussels sprout in the very end. I hope that this was educational for you. It's been certainly educational for us at Bejo to try to grow Brussels sprouts here in New York. Every year that we do it, we learn a little bit more, and hopefully I'll get a chance to talk to some of you, and maybe you can relay some of your experience to me, and we can continue to learn to grow how to grow bodacious Brussels sprouts together. Thanks very much.
Thank you, Jan. Emma, did you see any questions in the chat?
We just have one about what the time frame for late versus early planting was in those pictures that were shown. I think that was, yeah.
And if you could stop sharing your screen, Chris could load up while you answer that question.
Yeah. The pictures that we showed, the grower was not entirely clear on when they planted, but they started planting in May and planted all the way through July. So I think some of these, the early plantings were probably maybe a late May planting. The grower planted pretty much every 2 weeks. And so the early planting was probably made in early June, and the later planting was probably towards late June, early July. But that was in Pennsylvania, so a little slightly different situation as it was here in New York.
So Brussels sprouts have an F word too, funky.
Yep.
Thank you, Jan.
You're welcome.
All right, so our last presentation is going to be a two-part between Chris Smart and myself, and Chris Smart is a Cornell vegetable plant pathologist. She is a treasure and a pleasure to work with. I really enjoyed working with her on Alternaria leaf spot and head rot in broccoli, and she's gonna, this is a very exciting disease to work with. And so she's gonna start the presentation, and then I'm going to finish with the fungicide trial results. So right. Chris, whenever you are ready.
Thank you, Christy, and thank you, Jan, for introducing Alternaria. And Jan has showed me samples, and I say, yep, that's Alternaria, just as he said I would. So I always like to introduce the people that do the work that I'll be talking about today. And Colin Day, as well as he's the research associate lab member lab manager in my lab, and Harut Bita, who is a postdoc in my lab, are the folks that are spearheading our Alternaria project. I thought I'd give a quick overview, although I can shorten it up. Jan showed you some really nice pictures. Alternaria leaf spot in New York is caused by fungus Alternaria brassicas, which is kind of a fun word to say. Has these, especially when it's dry outside, you'll see these tan lesions that are have that characteristic concentric circle target look to them. And when you have humidity, you get lots and lots of deep dark black spores on the leaves. And this is cabbage, and up here, I think that's cauliflower. Many of you may remember I had a student a few years back that did a lot of studies on Alternaria brassicas and cauliflower. The spores themselves are actually quite heavy compared to other pathogen spores, so they can't blow in the wind very far. They blow short distances, and they tend to start on the lower leaves, as Jan said, Alternaria likes that older, dead, or dying tissue. It's where it really can take hold. And then it starts on those lower leaves and the rain will splash it up higher in the plant. In order to get the spores, you have to have either free water, rain, or high humidity, and a warmer temperature, at least between 65 and 85 Fahrenheit. We tend to see this later in the season, although recently it has shown up earlier than say I saw it 10 years ago. The spores of the pathogen themselves can be on seed, commonly found on debris in the soil, and it will also attack cruciferous weeds. So I thought I'd show some early lesions. This is a broccoli leaf that has some tiny specks on that are early Alternaria lesion. And this is actually from a transplant. I'd say every year I get some transplants that will have little black spots on like this. This is what Alternaria spots look like on a transplant. But let me just say, there are several other pathogens that look exactly like this. And in order to really figure out what that lesion is on the transplant, I always have to isolate. It's really hard to determine small dark brown speck on transplant. It's hard to figure out which pathogen that might be. So here is a close-up image of that Alternaria leaf spot showing that target-like lesion. And I always show this picture because it was from one of my research trials, and you can see the control pesticide residue on the leaf, and the Alternaria was unfazed. That was not because the Alternaria was resistant to that particular product, but it was rather that the product was not applied early enough to really nip that Alternaria in the bud. And once it takes off, it's really hard to control. In terms of host range, I need to visit Jan's trials because he had some nice pictures of Alternaria on Brussels sprouts. I need to update my photo gallery, Jan. We, as I will talk about, have spent a lot of time on broccoli this summer. Head rot on broccoli, you'll see part of the broccoli head that's not growing as well. And if you take a closer look, you'll see the dark lesions. And then once you have that dark lesion, you actually start to get just a general rot on the broccoli head. You'll see it on kale. As I said, it's a huge problem on cauliflower as well, but it will attack all brassicas, is listed on the right-hand side of the slide. So Christy and I are part of a fairly new project. The official name of the project is Control-Alt-Delete. For those of you who use a PC, you'll know that we have to use Control-Alt-Delete to turn on our computer every day. But the idea there was to control Alternaria, and with any luck at all, we would like to delete it. The project runs from October of 2020, maybe September of 2020 through August of 24. And it's a joint project between Georgia, Virginia, and New York, where we have field trials. And then a scientist in Connecticut who is doing fungicide sensitivity and pathogen genotype diversity. So in addition to the diversity and fungicide sensitivity, we did a variety trial that I'll be talking about today. We looked at nitrogen rates, similar to what Jan discussed. And then we had an overhead irrigation trial, which, to be fair, Christy and I, when we were talking to our colleagues from Virginia and Georgia, said, you know, overhead irrigation trial, it's probably going to rain, but they're like, oh, come on, let's do the overhead irrigation trial. We had never had so much rain during a trial as in our overhead irrigation trial. So we were looking at the difference between morning, midday, and evening irrigation. The idea being, if you irrigate in the morning, the plants will dry out during the day and you'll have less disease compared to if you irrigate in the evening, you know, at 6 o'clock or so before sundown, then the plants, you're extending that time of leaf wetness, which is necessary for Alternaria to take a hold. Our plants, when we planted, it was a beautiful day. The soil was exactly correct. And then it rained and rained and rained. And Colin put down this beautiful irrigation system that was only used on the day we planted. We never used it again the rest of the season. So our irrigation trial was rained out. And then we did fungicide trials that Christy will discuss. So I thought I would show you a picture of the pathogen in culture. It really does have a dark black velvety look to it. Every isolate that we collected this summer as part of the diversity trial, Harut isolated 121 from 121 different samples, 4 fields in different parts of the state. You can see this is a very severely infected leaf here. All of those isolates were Alternaria brassicas. Interestingly, and all the isolates that have been tested to date were sensitive to azoxystrobin, the active ingredient in Quadris that many folks would use to control Alternaria. That's the only fungicide that has been tested so far, and only 10 of our isolates from this year have been tested. The complete panel has not yet been tested, so we'll have more information on that later. In addition to testing for fungicide sensitivity, we'll be looking at pathogen diversity to see how different the pathogen is within a field and across different sites, both within New York as well as Virginia and Georgia. That'll be really interesting to know. We don't know a lot about the reproductive strategies of this pathogen. So is it exclusively asexual? Is there sexual reproduction? And what is that doing? Is that increasing our chances of getting of losing fungicide sensitivity? In Georgia, they found isolates that were not Alternaria brassicas, but were a different species, Alternaria japonica. And what the group found was that those isolates, that species, is naturally less sensitive to azoxystrobin than the Alternaria brassicas. So we'll learn more about that. We have not found that yet in New York, but we will continue to take samples and follow that closely because we want to make sure that when something is being applied to a field, it's going to be effective. The other thing that my lab has done is looked at the host range of these 121 isolates. So each isolate was inoculated onto broccoli, cabbage, kale, collard, and cauliflower. And what Harut has found is that across all of the isolates, broccoli and collards are the 2 most susceptible, and cabbage of the isolates we had was the least susceptible, but all of those are hosts. And interestingly, the other thing she found was that you can sort of see it in this picture. These are 4 different isolates all inoculated onto a small broccoli leaf. And you can see this isolate has really taken off, whereas you don't see the Alternaria quite as much on the other isolates yet. And what she has found is that there are some isolates of those 121 that are much more aggressive than others. In fact, she had 2 of those 121 isolates that did not cause disease, which is interesting since she isolated it from a plant that had a lesion. So we're really digging into those data now. She's just collecting the last of it. And I think that will be really informative to see what the differences are between the more aggressive and the less aggressive isolates. So for our field trials, as I said, we planted in May, and we used the planter. Thomas Bjorkman got a beautiful broccoli planter that we were able to use. We planted double rows. We broke our trials into 20-foot plots, and we had 4 reps of each treatment. And that's Colin there, making sure everything goes in smoothly. And as I said, he had the irrigation all set, and then it rained and rained and rained. We inoculated, we planted in very late June. We inoculated with Alternaria. We were on a research farm. So we inoculated in early July. And I think actually Harut and I inoculated on July 4th, and on July 5th, it was started to rain, you know, not heavily, just we had light rain and fog and, you know, 65 to 70 degree weather for like a month. And we had rapid, I call it rapid and severe disease. So this was a broccoli leaf. I think this was maybe 10 days to 2 weeks after we inoculated. One of the things I really noticed on the broccoli was that the stem lesions shown in this middle picture, we had so many stem lesions. We had more stem lesions than leaf lesions, and those stem lesions would just have millions of conidia on them. And I don't know if that was a function of the cultivar of broccoli that we used or the isolate, but I'll be looking more into that too. Just so many stem lesions, and we had severe head blight as well. So we did do a nitrogen fertilizer trial based on the amount of nitrogen in the soil test. We were assuming the recommended rate for our field would be 120 pounds per acre. So that was our 100% nitrogen rate in this table here. So we have the percent nitrogen from recommended from 150% to 125%, the recommended rate, which would have been 120 pounds, 75 and 50%. And then we calculated the amount of disease or AUDPC, but you can just think of this as the amount of disease. The bigger the number, the more disease on both the leaf and the head. And as you can see, the lowest rate of nitrogen, you know, the plants were just not as vigorous, not as healthy. And we had the highest amount of disease. And while it was not statistically significant on the amount of leaf lesions for the head blight, there was statistically more disease on the heads with the least amount of nitrogen. So I do think that the data in this trial were impacted by the amount of rain we had. I think there perhaps was more disease in all of the treatments because the nitrogen, when we side dressed it, it was so wet, the nitrogen was washed away. But clearly the least amount of nitrogen was making the plant more susceptible to the Alternaria. And then finally, before I turn it over to Christy, I'll talk briefly about our variety trial. We had the same 27 broccoli varieties in Georgia, Virginia, and in New York. And we planted this one in August. We were worried about having all of the other trials plus the variety trial out in the field at the same time. So we planted this late season. I think this year we won't do that. We'll plant everything earlier because these plants, we planted them, they ended up in the field so late that they never really got decent heads. Again, we used the double rows, 20 feet per plot and 4 reps of each of the varieties. And Harut and I rated them 6 times. We did not inoculate this because we planted it in the field right next to where our early season trial was, and there was just so much inoculum that everything was immediately inoculated once we put it into the field. So then I thought we had a lot of rain prior to August, but the days after we planted our variety trial, it actually rained so much that our field flooded out. And you can see this just freshly transplanted broccoli that they drowned, and many of the plants in the left side picture here did drown. We lost some reps because of that. We're hoping for less rain or more well-drained soil in 2022. So I didn't include all 27 varieties in this table because it gets too, well, I think it gets too busy. Actually, in New York, Colin was really interested in looking at a sprouting broccoli cultivar. So we included one of those, and it turned out that that cultivar had the least amount of disease. But I don't know if it's because that cultivar has more resistance, or if it's something about the maturity of that sprouting broccoli cultivar that when the plants got inoculated, it just wasn't as susceptible to disease. So there's more to be learned there. But the other cultivars that, and this was fairly consistent across locations, Montebello, Asteroid, Diplomat, and Bellstar tended to have less disease. Now, if you look at the little numbers above the bars, you'll see that there's an A on Diplomat and Bellstar. And I will say for Diplomat, we lost 2 of the 4 replicates in the Great Flood of 22. So there is that. But our most susceptible cultivars were Green Magic and Emerald Star. And as I said, we're going to be doing this again this year. And hopefully our environment will be such that we'll be able to look more closely at differences in susceptibility on the head and have more data for you this time next year. And with that, I am handing it off to Christy to talk about fungicide trials.
I am very excited to share with you fresh research results from 5 fungicide trials that were conducted in New York last growing season in 2021, both conventional and organic fungicides. So in addition to the Control Alt Delete project, I also had some funding from IR4 to look at a pipeline product. I'm also going to share results from a trial that Ethan Grunberg and Tressa Resenek did, funded by the Hudson Valley Food Hub. And again, acknowledging my technicians, Emma and Sarah. And also I did an on-farm trial with Klutz Farm in Kendall, or the trial was in Holly, but the growers are from Kendall. So these are the treatments that were evaluated in these trials. They included Bravo, which is a multi-site mode of action, M05, Quadris, FRAC 11, Switch is a 9 and a 12, a whole bunch of 7s, Preaxer, Maravon, Luna Sensation, Luna Experience, Miravis Prime, Endura, and Fontellus. Take note, Fontellus is not labeled in New York, but it is in other states, so it's in our trial as well. Luna Experience is not labeled on head Brassicas, but it's labeled some other Brassicas. Maravon is not labeled on Brassicas. Its sister fungicide, Preaxar, is. I also looked at a FRAC 21, a new Corteva pipeline product. Several FRAC 3s, Inspire Super Quadris Top Guard. I also put in Sevia, which is a brand new FRAC 3 from BASF. It's not labeled in Brassicas, but just another active ingredient. And very pleased that we had 7 different organic products belonging to different FRAC groups or having different mode of action. Out of these, Microthiol Disperse, it's labeled on Brassicas, but it's not specifically labeled on Alternaria. So I'm going to start with the conventional fungicides. We had 3 trials. So the one that Chris Smart did at AgriCheck in the summer, the broccoli was planted on May 26th, sprays from June 28th to July 6th with the harvest July 26th to 29th. Artificial inoculation, which you previously described, very severe pressure. Then I set up a trial on farm in Holly. This was in a conventional commercial large broccoli field with Klutz. The field was planted July 5th. I sprayed August 5th to September 12th. The harvest was from September 3rd to September 12th. I was relying on a natural inoculation, and I sprayed and I sprayed and I sprayed. And after the 5th spray, I still had not seen disease. I went out to collect the stakes, and by golly, disease had finally come in as they were harvesting the trial. So I went out and sprayed one more time. So those last 2 sprays, 5 and 6, probably went towards controlling the disease. I rated that as low pressure. Then I had a trial at AgriCheck in the fall. So this is the same timing as Chris put the variety trial in. So it was planted August 4th, sprayed August 25th to October 25th, harvest October 20th to November 2nd, relying on natural inoculum, but of course it's right beside her festering fungicide trial from the summer. So it ended up having moderate to severe pressure. Emerald Crown was a variety that we were using, except the growers were using Eastern Crown. which is a little bit more tolerant to Alternaria. And I use dynamic. Chris is not using any adjuvants, and we're spraying pretty much on a weekly schedule, 5 to 9 times, depending on the trial. So we'll take a look at the results. So this is Chris's trial, summer trial at AgriTech in Geneva. What we are looking at is percent Alternaria leaf spot severity at the final assessment. So looking at the plot, what percentage of the foliage is covered in Alternaria. The untreated, 33%, that's pretty high. And then all of my plots are organized in order from the best performing treatment to the worst, and I flank off what's not significantly different from the best treatment, and then I flank off what's not significantly different from the worst treatment. So we'll take a look at the best in trial. They're all Frac 3s and Frac 7s, Inspire Super, Preaxer, Miravis Prime, Quadris Top, Luna Sensation, Fontellus, with the exception of Top Guard, a Frac 3, and Endura, a Frac 7, that are kind of in this middle of the pack category. Better than Bravo, better than the untreated, not quite as good as a front runner. I'm not sure why this active ingredient is not as good as some of the best performing ones. With respect to the Frac 7s, Endura is an active ingredient that when a pathogen is developing resistance, this tends to be the first one to slip. So I hope that we're not seeing the very beginning of fungicide resistance, but that's what this project is all about, is to be monitoring that very, very closely. Here's Quadris. Chris is using the high rate, 15.5. Here's Quadris Top. No significant difference between the two. Here's Bravo, 42% reduction in leaf severity, better than the untreated. All of the other fungicides are better than Bravo. And Switch coming in the same as Quadris. So now we'll go to Holly. And so I mentioned I had low pressure. So I couldn't, it was really tricky for us to estimate percent severity. So we actually just counted lesions. So we had 88 lesions per plant in the untreated. You can see everything significantly reduced the number of lesions on the leaves. Our front runners, Frac 3 and 7s again, Inspire Super, Quadris Top, Luna Sensation, Maravon, Preaxer, and Miravis Prime. Except for the new Frac 3 from BSF, Sevia. Significantly not as good as Inspire Super and Quadris Top. Still having activity. Here's where Quadris alone, middle of the pack, not as good as a front runner, definitely better than an untreated and Bravo. This is the lower rate, the 11-ounce rate, which was significantly not as good as Quadris Top, which is along the lines of what I found in my 2018 trial. Here's Bravo, better than the untreated, 71% control, not as good as a front runner, not as good as Quadris. Switch coming in again, very close to Quadris. And then here's that Frac 21 that I tried. It's in line with Bravo. So now let's take a look at head rot. How good do we do at keeping the rot out of the heads? Because at the end of the day, that's what it's all about. So this is Chris Smart's trial in Geneva. This is percent head severity. The untreated has 37%. You can see all of the treatments reduced head severity by a lot. However, still 100% of the heads were unmarketable because they all had at least one lesion. And I wonder if stress came into play to some extent with this, because there's an interaction between stress and Alternaria, as Jan demonstrated with the Brussels sprouts. The same thing can occur in broccoli. So even if we have excellent fungicide programs, you can't fix a stress problem with fungicides, I guess is what I'm trying to say. Now, the front runners, Frac 7 and 3, with exception of Quadris, and 11 is right up there with the 7s and 3s. Bravo, significantly better than nothing, 87% reduction in severity, not as good as any of the other fungicides. Middle of the pack, Switch, Endura, and Fontellus. Here we're back in Holly in the growers trial. Here I'm evaluating actual percent head rot. So even though the disease only came in at the very, very end, I still had 22% of those heads that were unmarketable. Here's the Frac 3s and 7s. Quadrus Top, Inspire Super, Preaxer, Mirvis Prime are front runners. Here's Luna Sensation, Miravon, a little more middle of the pack, and Sevia, that BASF Frac 3, not significantly different from the untreated. Here's Quadrus. I'm using the low rate again. This is Quadrus is not significantly different than the untreated, but it's also not significantly different than the best treatment. There's a lot of variability in this trial. But numerically, we're talking about 46% reduction compared to 100%. So starting to, with the low rate of Quadrus, I'm seeing more of a separation between Quadrus and Quadrus Top. Here's Frac 21, not different than an untreated. Bravo, middle of the pack, Switch up with the front runners. Here's the IR4 trial that I conducted in Geneva. This is Alternaria leaf spot severity at the end of the season in the moderate to high pressure trial. So 18% in the untreated. And I wanted to show you how good Luna experienced. This is a 7 and a 3, 93% reduction. Quadrus Top, 55%, halfway there. That's the low rate. But what I wanted to point out here with the Frac 21 product, so this is a high rate without an adjuvant, 22% control, better than nothing, but not great. Now add just a little bit of dynamic and adjuvant. I've increased the control. I've doubled the control, reduced the amount of Alternaria leaf spot severity by half. And here is the half rate with an adjuvant, which is as good as a high rate without an adjuvant. So I think this is a really good illustration of how adjuvants may be helpful, particularly with fungicides that have translaminar or systemic activity that need to get into the plant. So that's your Frac 3, 7, 9, 11. And then also, as you know, Brassicas have very waxy cuticles, and I think the adjuvants can help them stay on the leaf a little bit better. And some of the fungicides are formulated very well with adjuvants already in them, but just something for you to consider. So here's a visual of Chris's trial at harvest. So this is the 36% of the leaf foliage covered in Alternaria in the untreated. Here's one of her best treatments. I think something like an Inspire Super. And you can just see how it can really go a long way in cleaning up this disease under very high pressure. This is the grower's field in holly. So you can see some in the Alternaria, some spots on the upper canopy leaves. The heads are starting to rot. And here's Luna Sensation, a Frac 7, just cleaning up the upper canopy leaves, keeping the heads clean. And here's my trial at the IR4 trial, the fall trial at Agritech, the untreated. This actually ended up with 85% rotten heads. And you can see the lower frame leaves are turning yellow. You can see the spots. And here's that Luna experience, that 3 and 7 in the same combination, just spectacular, shiny, and new. When these fungicides are working well, they're fantastic. So here's the lineup of what you have for conventional fungicides in New York. I've listed them according to frac group. So you've got Bravo, the M5, Quadrus 11. So in the past, we were really holding off on recommending Quadrus and the Frac 11s because we were suspicious that they were developing resistance. As Chris let you know earlier, we have not detected that yet. And as I showed you from our trial results, they do appear to have activity and they're working. So we're going to go ahead and recommend them again. There's a lot of generics. This might be one of the more affordable fungicide options you have. Switch is a 9 and a 12. There's a bunch of 7s belonging to different subclasses. Some of them are premixes with 11s. Mirvis Prime's a premix with a 12 from Switch. And then you've got Inspire Super, Quadrus Top, and Top Guard. Quadrus and Switch and Inspire Super have generics. So there may be some more affordable options on the market. I've also listed the rating for risk of fungicide resistance. Take note that the 11s and 7s are medium, high to high risk. These are the ones that you want to be very mindful of not overusing and abusing, or this pathogen will likely develop resistance. And as we've showed you right now, they are working very, very well. I've included the pre-harvest interval, flagging the 0 or 1 days to harvest. So these are the products you can use while you're harvesting. 3 of the Frac 7s are restricted use, and Endure is the only one that is not. So If you don't have a spray license, these ones would not be available to you. And then a relative ranking of the control. So the Frac 7s are excellent. The Frac 3s, Inspire Super and Quadris Top are excellent. Endura and Top Guard are very good. Bravo is mediocre. Quadris and Switch are good. And then I've also flagged which ones have activity against downy mildew and which ones don't. So our recommendations for Alternaria are to spray fungicides preventatively before Alternaria establishes itself. Chris said it's much easier to get ahead of it than try to catch it. The lower frame leaves can serve as inoculum for the heads. And if you've got lesions on upper canopy leaves, they can literally run down the leaves onto the head. Bravo is a good choice when disease pressure is low. If you're in high disease conditions, the canopy has filled in, aeration is reduced, leaf wetness is prolonged. If you're scouting broccoli at 2 o'clock in the afternoon and you're getting wet, it's probably conditions that are favorable for disease, especially if it's known to occur in the area. So that's the time when you want to get out your very good to excellent fungicides and run them right through harvest, because it's all about keeping the Alternaria out of the heads. The use of the highest label rates is a very good idea for resistance management. And I demonstrated the 15 ounces versus the 11 ounces of Quadris that we were getting better control with the higher rate. All of the fungicides except Bravo are at some risk for Alternaria developing fungicide resistance. So for best fungicide resistance management practices, do not apply more than 1 to 2 applications per frac before rotating to a different group. That's going to be labeled on the label. We are recommending to try not to use more than 2 apps per frac per crop, especially for the Frac 7s and the 11s. And be mindful that a lot of these are premixes and you have to be managing both frac groups or both active or frac groups in the premix. And consider using an adjuvant for the products with translaminar or systemic activity. Save the products with 0 or 1 days to harvest to use during harvest. And note that many of the ALS fungicides do not control downy mildew. Bravo will give you good control, the Frac 11s, mediocre. If you need excellent control of downy mildew, Arondis Opti or Ultra and Revis and Presidio are probably the best products. And we encourage you to design your fungicide spray program ahead of time. So this is an example of a program starting with Bravo until canopy fill in, and then for a 4-week program, assuming conditions are high, giving the best control options you can with our best products. We're basically rotating 3s and 7s, being mindful not to rack up too many 11s in here. So I've only got 2, which is why I didn't use Luna Sensation here, because I would have had 3 11s in a row, and saving the ones with the 0 and 1 pre-harvest intervals during harvest. The Frac 7s are restricted use. So if you don't have your spray license, here's another example of a program. Okay, moving on to the organic trials. So again, Chris Smart did an organic trial basically beside the conventional trial in the summer at Geneva. I just put some organic treatments in the trial I had in Holly on farm. And then I'm going to share results from a trial that Ethan Grunberg and Teresa Resnick did in the Hudson Valley. The trial was planted August 17th, sprayed between August 25th and 11th, harvested October 13th to 25th. They had low to moderate pressure. They were also using Emerald Crown and used the adjuvant Attach. So we'll take a look at some results. So this is Chris Smart's trial. We're looking at percent leaf severity at the end of the season. Here's our untreated. Here is conventional fungicides, a Frac 7 and Bravo. And look what organic product we have that is as good as a conventional fungicide, landing at 60% control, so 13 fluid ounces. This was very exciting to see, because truthfully, I thought that organic growers were really going to be struggling controlling Alternaria with the products that they had available. The middle of the pack fungicides here, significantly better than the untreated, not as good as the front runner. Microthiol disperse, 40% control, Lifeguard, 31% control. Not significantly different than the untreated is Coside, so this is a copper. Double nickel, regalia, not really doing anything in this trial for Alternaria. Here's her head rot data. So you can see in black there, the FRAC 7 and the Bravo are highlighted. And yep, also at 13 fluid ounces, as good as a conventional fungicide. In the middle of the pack here, better than the untreated, but not as good as a front runner, is Lifeguard and Microthiol Disperse, about 50% there, not quite all the way. Here's Coeside, not significantly different than the untreated, also not significantly different than Lifeguard and Microthiol Disperse. It looks like it's really trying to work. And it actually, in Georgia, the coppers were working in their trials. Double nickel and then regalia. Okay, going to holly. So I flagged in black there, the FRAC 7s and Bravo. And then I had OSO at the 6.5 fluid ounce rate. So it's as good as Bravo, 81% control, not as good as a front runner FRAC 7. I'm so curious if I would have had that 13 fluid ounce rate, I bet you it would have been as good as a 7. Okay, here's copper in my trial. This was also Coeside 3000, the same as copper, 70% control, and carbonator, 2/3 of the way there. Definitely having some activity on being able to reduce the lesion count. Here's my head rot data. So again, in black are the FRAC 7s and Bravo. Here's OSO. Again, it's in line with Bravo, 2/3 of the way there. So instead of 22% rotten heads, only 7. And here's copper, 80% control, not different than OSO. Numerically, it's giving us a little bit better control, only 4% unmarketable heads. What didn't work was carbonator. So it was able to keep it off the foliage, not so good of a job keeping it out of the heads. And then here's Ethan's trial in Hudson Valley under moderate pressure. So we're looking at Alternaria leaf severity at harvest, 13% in the untreated. We're seeing a lot of bars, like this is not looking like Chris's in my trials. The control is not as good here. But the only treatment that was significantly better than the untreated is OSO, the 6.5 ounce rate with badge. And so this section, these were all treatments that were regalia, Lifeguard, Stargust, double nickel, howler, thia, tank mixed with badge. And then this section is the same thing, only this time they're alternated with badge. So if you compare this as a group to that as a group, you can see the copper, when you're applying it every single week versus every other week, is having a little bit of activity. And here we see that the high rate of OSO, alternated with badge, has the least amount of Alternaria, although it's not significant. So why are they not getting the efficacy that Chris and I are? Well, this is not proven, but one theory is that a couple of the spray intervals were 10, as many as 15 days apart. And I think for these biologicals, that needs to be tightened up to closer to 7, maybe even tighter when conditions are higher. So here is your lineup for organic fungicides. So we have OSO, Coeside, Lifeguard, Carbonator, all having some activity. Regalia and double nickel, we are not recommending those at this time for Alternaria. The best one, of course, is OSO, good to very good as a conventional product. It also has the highest risk for developing fungicide resistance. It's not in the same class as the 7s or the 11s. Coeside and Carbonator are low. Not sure exactly what it is for Lifeguard. All of them 0 days PHI. None of them are restricted use. OSO is going to be expensive. The low rate is probably around 40. The high rate's about 80. We don't want you going out there and spraying that 6 times in a row because we don't want it to develop resistance. But when pressure is low, you can probably be using Coeside, Lifeguard, Carbonator. And then when pressure is high and you really want to keep the heads clean, that's when you focus on OSO. The higher the rate, probably the better the control. Just be very careful with adjuvants and particularly copper when temperatures are hot. So just follow the label for that. This is an area I'd like to look into more this summer, if we can get some better activity out of the biologicals with the help of adjuvants, we'll see. So I know that was a lot of information. So to not blow your mind, we do have a fungicide cheat sheet for Alternaria leaf spot and head rot in broccoli and other cold crops. It's been edited, revised for the 2022 growing season. It's available on the Cornell website, the Cornell Vegetable Program website. Got all the products, the rates, the active ingredient, the FRAC groups, the relative risk of fungicide resistance, the PHI, whether it's restricted use, crop rotation rotation restrictions, maximum use rates, what crops it's labeled on, a relative rating, and whether it has activity on downy mildew, and a step-by-step process, how you go about putting together your spray program. Alrighty, I am going to stop sharing. And if there's any questions in the chat, or if anybody has any questions for my presentation or Chris's presentation.
We do have a couple of questions. First, Kevin would like to know if participants will get a copy of the materials for control of Alternaria.
So that it should be covered in the cheat sheet. Everything that's labeled for Alternaria in Brassicas in New York is on that cheat sheet.
Okay, I'll try to find a link to that and drop it in the chat.
Sure.
And then Elizabeth wants to know, do you think sulfur has a place in an organic rotation to improve economics? Some of the charts looked like it offered a bit of protection.
Yeah, and we have, so you're talking about microthiol disperse, I assume, which is a copper product. The only reason I did not put that in the cheat sheet is because it's not specifically labeled for Alternaria. But as we were talking about with cabbage maggot and swede midge, sometimes you're going to get incidental control when you're spraying for another pathogen. Okay. Well, if anybody is trying to drop out, I'd just like to encourage you to sign out with the link, because I have another evaluation form there. So you need to sign out if you need your DC credits, but I would really welcome getting some feedback from this session. It's certainly not the same as walking into the audience in person and talking to everybody. I'm going to shut off my screen and I'll be at my dining room table.
And I would also say that if anyone does have an Alternaria outbreak this summer, we are collecting isolates. We'll be looking at diversity and fungicide sensitivity. So give us a call and we'll come out and grab a bag of leaves. Thank you.
Once again, thank you to our sponsors, Arctic Refrigeration and Bejo Seeds. Thank you to all of the speakers. Thank you all for joining us today on this wintry Friday afternoon. And as always, wish you nothing but the best for the 2022 growing season. And you've paid your money, so you can attend any Expo sessions you want next week and the week after. There are several. You can load up on DC credits, that is for sure.
Thanks, everyone.
Thank you, everyone.
Thank you, Christy.
This has been a production of Cornell University, on the web at cornell.edu.